issues we have to deal with when we're designing systems. It's obviously a problem at various times. In our industry, we have an interesting phrase, the tyranny of a large number. And so in what we'll be talking about today, we'll be looking at data which used to be a problem, the larger data sets which are now fairly normal and straightforward for us in relational databases. And so I'll be talking about how to make your relatively simple data even simpler. And so that's the main goal of Spring Data, particularly with the more regular sized data sets that JPA, etc. deal with. And then I'll hand over and people will talk more about Hadoop, which is what is now the new tyranny of a large number and how to get real actual value out of your larger data sets that have been until now possibly too large to really get them. We had two technologies, one which is near and dear to all of our hearts, relational data, with JPA or some other object relational mapping system. And so this is what we now see as fairly common, standard, simple data. We're just going to make it simpler. There's a lot of boilerplate code still involved in dealing with relational data. We want to get rid of that as much as possible. And then we'll start looking forward to some of the NoSQL databases, in this case MongoDB, which is a document-oriented database. And we'll look at how to simplify, or how we're helping simplify your using that system, migrating either existing systems to these kind of databases or migrating your development process and your thinking process. So I'll talk a little bit about Spring Data itself. We'll do some basics on Spring Data. What are the components? What do they do? Why do they do it? The ubiquitous quick start. This has come from our American colleagues. They love quick starts. Everything's a quick start in America. So we'll do a quick start. We'll show you some actual code on the screen, what it's going to look like, what you can expect to see. And then we'll get into the details, and that will be more actually in an IDE and looking at actual code files. So Spring Data is an umbrella project to simplify the persisting of POJOs, plain old Java objects, to some kind of back-end storage. This is important. There are various systems like MongoDB, various document databases, CouchDB as well, which don't think necessarily in terms of objects. And so I've seen some people express surprise, some even disappointment, that Spring Data insists on moving things in and out of objects, even with things like MongoDB. The focus of Spring Data is to get the data from whatever system you're using into your programming system. And we're focusing here on Java, but Spring does have a .NET application framework, so possibly these things could go into .NET as well if that were important for the customers. So the Spring Data is overall an umbrella project. It provides the underlying model, the clear vision as to, oh, we could do it this way. So the world struggled with a good, elegant system to map data from databases up into object-oriented systems, whether they be C++ in the old days or Java these days. Sun tried it 3 times, Sun wrote Java. They had 3 different object-oriented mapping systems that were all rubbish. And so they're onto like their 4th or 5th iteration now. So it was not an easy problem to begin with. And then having had this insight as to how we really can make this simple, then there are a range of sub-projects which then focus this in an opinionated way into the various new technologies, various technologies. So, yes, we still have lots of relational databases out there. So we still want to be able to talk to our SQL databases, so either to the JDBC directly or more than likely with an ORM and JPA. But we have more and more situations where non-SQL databases are important. I do have customers in Australia that are going to migrate large applications from relational data to no relational data stores. I have a number looking directly at MongoDB, a number deployed and looking at deploying on Gemfire, etc. So this is certainly an area that we want to be more aware of from now and into the next 3-5 years. And then some other interesting ones. So it turns out that Spring Data isn't confined just to databases. Certainly Hadoop is storage, although it's not really a database per se, but even just the straight RESTful system has been built as a sub-project, as a back-end for Spring Data. So Spring Data, the core project, provides the underlying model, and it's a very simple model. That's the whole point. We're trying to simplify this and make it easier for you to deal with your standard types of data. And then various directed sub-projects at some kind of backend. And so we're going to be talking about JPA and MongoDB, or I will be talking about JPA and MongoDB, and then we'll start talking about Hadoop. So, the goal. Why did we feel that yet another layer was needed to try and deal with data that was being dealt with fairly well? You know, we've all written Spring programs or other types of applications, and we've all dealt with relational databases, and it works, yeah? So it's not like we're solving an unsolvable problem. So what are we trying to achieve? First of all, reduce the boilerplate code. That was the original focus of Spring when it was started up way back in 2004, and it's still a driving force. So whenever we see a system where we're writing the same code repeatedly, then we see an opportunity to go and fix that. Anyone here done a Spring course? I presume someone at least has. Yeah? Did your instructor remind you about the little mantra in Spring, DRY? Don't repeat yourself. And separation of concerns, and if you write it in a funny way, it says dry socks. And so the original thing of Spring was to give programmers a warm and fuzzy feeling by having dry socks. Okay, so we're going to help reduce the boilerplate code. That's less code for you to write, less code for you to test, less code to go wrong. As Steve Jobs put it, the line of code that costs you nothing to write, costs you nothing to maintain, and will never get a bug, is the line of code you never wrote in the first place. So we're going to also automate common tasks in code, and automate the configuration. So basically, this is an opinionated system. It's a new buzzword. If you're looking for the new buzzword, opinionated is it for the moment. So opinionated systems are based on convention over configuration. So they make useful, intelligent assumptions, and you only tell it with instructions when you want to go differently from the standard conventional approach. So Spring Data is very much a convention over configuration, i.e. leave it alone and it will make intelligent decisions. When you need to change that, that's when you actually start writing something extra. The real genius in Spring Data, from my view, when I first saw it, was that it avoided the lowest common denominator syndrome. So yet another layer over multiple data backends. Yeah, right. Anytime I've seen a unifying system, the common problem is that they all focus, or they manage to support only the features in all the backends that are in common, which means that they ignore the features which make the backends different, which is what made them interesting. But why do you go and use MongoDB? Because it's different to a relational database, right? If it's the same database, why would you change? So the real clever bit with Spring Data was to find a model which enabled us to give you a generalized approach to solve a lot of different technologies, but not lose the different power of those systems. So how do we do it? Here's the model, all 4 bits of it. So the central one here is the repository, and in a couple of slides I will give you more detail on that. I presume we're all fairly familiar with repositories one way or another in programming, yeah? Okay. So basically the focus of the repository is to retrieve data from somewhere and convert it into an object for us, and to then take objects and go and save them somewhere, okay? And as such, they're operating as an adapter pattern. And we'll talk about that a little bit more. There is a task there of mapping data from one format to another. Unless you're using an object database, the data isn't arriving into our memory as an object. It's a row, a column, a table, a document, a triplet, an octet, whatever. So there's some kind of mapping. Spring Data focuses on inferring the obvious and then letting you tell us with things like annotations when our inferences may not be correct. There's a template class in there. When I teach core Spring, I joke that Spring sees every problem as an opportunity to write an aspect and a template class. So here's the ubiquitous template class. It's based on the template design pattern. The template design pattern says that we'll give you a simple, high-level API for doing what you need to do, and we'll look after the underlying resources, etc. And then data retrieval, you need to be able to do it in some kind of query form, so there needs to be some kind of query ability, and yet we need to make this generic. So in Spring Data, the repositories, the genius part of it was that we said, okay, there's a method that's already working well, but we're hand coding it, which is the repository. We found the 3-layer system with repositories in the middle there is a really good pattern for abstracting the details of our database from a lot of our other code. But we have to go and write repositories. Anyone still look forward to writing repositories? You wake up in the morning, oh yeah, I've got 2 more repositories to write. Okay, I'm apparently the only guy who thinks that way. So we'd love to get rid of that, okay? So Spring Data is all about literally writing the repositories for you. So the repositories in this Spring Data pattern are very much an implementation of the adapter pattern. You call an API on one side and it adapts that to some very different API on the other side. And that then isolates your code from the various discrepancies, differences, evolution of that underlying system. But you can write adapter patterns in different ways. The repository, and therefore what Spring is leveraging with Spring Data, is that the repositories here adapt from a what concept to a how concept. And that's how they can give us this generalization over different databases. If they were adapting from one how to another how, we would still have the same kind of complexity. Out of interest, ORM and JPA is a mapping of a how to a how, which is why JPA will only ever really work on SQL databases, because the input API is still publishing out to the world a relational database view of things. But the repository doesn't. The repository is, what do you want to do? I want a user object. How? I don't care, that's your problem. So the repository is very much going to map a whole lot of what questions. What do you want? I want this, I want that, I want something else, okay? And then it will deal with the how under the covers. And that's why Spring Data is far more widely applicable than something like JPA. Then the mapping, this has been well solved. We're using existing technologies, marshalling, unmarshalling, POX, Jackson, etc. And then using, again, an approach that Spring has found very, very effective. Things like annotations to just declare what needs to be done without you having to write extra code. Template classes, they give you a nice high-level API, but directly at the underlying technology. So there's a Mongo template, there's a JPA template, etc., etc. So if you need to go and talk to the database, rather than dropping off a cliff and saying, well, if you can't do it in Spring Data, tough, go look after it yourself. We say, well, here's a system to make talking directly to MongoDB or JPA easier for you. We'll look after all the resources. You know, in JPA, we'll start and stop transactions, and we'll get connections going, and we'll clean the connections up when you're finished. You don't have to mess with all that stuff. In Mongo, there's a different set of problems, but they're still solved with exactly the same way. We give you a template, and it deals with all of the nasty stuff underneath. Queries, we give you the both worlds. You can specify your query information in native query syntax if the underlying backend has a native query syntax. MongoDB does. It looks like JSON. How many people out here, as a Java programmer, have high confidence in either theirs or other Java programmers' abilities to write SQL? Okay, I've got this brand new database I'm going to sell you. It's called MongoDB. It's got a new, hitherto unseen query language. How many among you have a high level of confidence that you or your mates are going to write good MongoDB queries? Yeah, right. Even less somehow. Somehow. Was that a yes?
Yes.
Excellent. Well, do you think it's easier than SQL?
Yep.
Couldn't be harder, could it? Okay. You want a prize, by the way? Can I toss this and not kill someone? There you go. Okay. First prize. Okay. So, if you need to go and write the queries, talk to the database, say, hey, I need this data just like this, we're there to help you. We give you a nice way, syntax of doing it, the template classes support doing queries. We give you annotations, add queries, stick the query in, and we'll do all the actual code of passing it into the database and marshalling it and getting it back out to you. We've also integrated with a really nice query DSL. This enables you to write your query in Java, which means the IDE can help you and the compiler can tell you when you got it wrong. What's the biggest problem with query strings? They're strings. What do strings avoid? They avoid being checked, type checked by the compiler. It's just a bunch of bytes, and when do you find out that your query string is wrong? At runtime. Possibly 5 days after the start of the application. Remember the other mantra in Spring, fail early. We want to know about problems as soon as possible, not as late as we can put them on. So the query DSL gives us a nice amount of power on that. In Spring Data, it means you have a Java syntax that you can write queries in, which will be mapped to the appropriate underlying query language. Write the query once, run it on multiple different database backends. Ooh, I feel the hairs going up the back of my neck. So there's some other really powerful things in there. So what we've done is leveraged the benefits of the repositories. This data layer that we already had in our applications, but we had to go and write. So we've optimized this, made it better. As I said, it's an adapter between the service layer, which deals with what? I want this, I want that, and the how, which is, I've got to go talk to a database or something else and make it happen. So, what is the magic with the Spring data repositories? First of all, they're auto-generated. So by and large, Spring itself is going to write the code. Literally, in fact, oftentimes it's not writing code, it's just understanding what you want and running pre-compiled code to do that. So that's where we get a huge saving in the boilerplate code. You declare your repository behavior in the most elegant way you can in Java, which is with an interface. So you declare what it should do in nice, type-safe declaration, an interface with methods, and then Spring fills the details in. Oh, you want that to happen? Okay, I can make that happen. I'll show you this in a couple more slides. You can override any of the methods that Spring would otherwise implement for you. So if you need a bit of control, absolutely have at it. But by sticking with the repositories, you're giving the what side of your API a very consistent look and feel, which makes it much easier for you, your programmers, your maintenance team to actually deal with this code later on. You can override the behavior of methods often just by adding an annotation, particularly for the query methods. Declare the method, put @query, tell Spring what query this thing should run, job done. Or you can go and write specific code. Well, I've got this really particular query that I really want to, do magic things with. Okay, go and write some magic. If we've saved you from writing 80% of the code, you now actually have a reasonable amount of time to think about the 20% of problems that are a bit more difficult and actually need some code and some analysis and some optimization. Rather than, I've got to write 10 more methods before I even get to that hard problem. So again, we're letting you focus on what actually matters. And you can extend these to add whatever else you need to the API. So, data mapping, we've seen this kind of stuff before. So, at entity, at table, at ID, these are the kind of standard JPA annotations that we have come to know and possibly love. So, there's some additional ones. MongoDB has an at document, which is analogous to at entity. This is something which is stored with an ID in a Mongo database. Gemfire has an at region because it's just mapping away amounts of data off into different places. So there are a number of additional annotations. Depending on the data model underneath, you can often get away with much less than you might think, or even zero. In MongoDB, certainly, you don't actually need any mapping annotations. If your fields map to the field names in the class, then the underlying system can make that work pretty straightforward. Okay, in templates, the high-level methods match the underlying technology, so if you can do a load, save, and query, then you will see those methods up on the template. We're managing the resources, and of course these things can be passively integrated into Spring components through our good friend dependency injection. And then the queries. So, you could do your native query, as I said. So here, we declared a method. We have not implemented a method. We declared a method. We told Spring, I want you to enable this to be run. Spring says, sure. What would you like it to do? Oh, at query. When this thing gets run, here's the query that goes with it. So we don't necessarily need to have our mapped queries offered as separate files. They're now in the actual source, along with the thing that's going to be associated with running it. So this is the method my service layer calls to make this query occur. Or we can go and use the query DSL. So we're going to find all by zip, and then we're going to call an internal find method that takes a query predicate, person.address.zipcode equals the passed in zip parameter. Straight Java. That'll map to JPA through ORM, it'll map to MongoDB in its query language, whether or not I can write it, and the code hasn't changed. So there's some definite strengths and power in this as well. And of course you can obviously mix and match, pick the one that's most appropriate for the job at hand. Quick start, okay, what does it look like? So, we're going to have these auto-generated repositories. We're going to tell Spring what they should look like with interfaces. So, here's my public interface, my user repository. It extends the Spring data provided repository, which is also an interface. So at this point in time, we're not dealing with code, we're not dealing directly with already implemented methods. We're simply dealing with software contracts. The Java interface is a very elegant definition of a software contract. The software contract says, if you give me one of these, I will return one of these to you. This is the what. And then under the covers, Spring is dealing with the how. often completely invisibly. So, I've extended repository, which is just a marker interface. The Spring Data repository interface has no methods defined on it at all. So I can go to town. So I need a save method, I need a couple of finders, and by and large, Spring is going to interpret what it is you need from the methods. So we have a number of signatures defined for save, delete, etc. If you use a signature that matches one of those, then we know how to implement that for you. Find is more generic. You couldn't possibly, and you wouldn't want to, try and define the exhaustive list of all the kind of queries that people could write in a single application, let alone their lifetime. So we're doing something here. People use Groovy or Grails or Ruby, things like that, which kind of interpreted web environments. Yep. So this kind of thing will start to make sense. Basically, we're going to interpret what the method should do based on the method name. So a find by ID, we're going to parse that and say, okay, so find a method is going to expect an ID, and we're going to return a single object. And find all by zip code, okay, we're going to be returning a list or initial rule, etc., etc. If you've got a couple here which you want to particularly specify how the query should work, then add query, give us the finder, and Spring will use that query for you. These other ones here, we're expecting Spring to fill them in for us automatically. Okay, so the repository interface is simply a marker. It turns on the Spring magic. Okay. We do provide some extended ones with some predefined methods declared in them. Notice the CRUD repository is still an interface. It is still just a declaration of a software contract. But it is a contract that Spring can implement for you automatically, rather than you're being forced to implement it. We've all had been involved with systems where they provided us with interfaces. And there's this great or interesting balance. It's like, we've got lots of power. Yeah, I love that, except lots of power means there's 30 methods I have to implement whenever I use your particular interface. Well, I've got a nice simple one, it's only got 3. Yes, that's good, less to implement, but it's less flexible. The system here that we have is actually the best of both worlds. We define a reasonable number of methods, but if you leave us alone, we'll implement them for you. So, CRUD repository defines 10, which gives you a couple of saves, a couple of finders, delete, and then a couple of management ones, count and exist. And this is the complete interface of the CRUD repository. There's one further one which extends CRUD repository, paging and sorting. It adds a couple of things there. You can pass in a pageable, so we'll do paging for you. Give me the next 10, give me the next 100, and page through the data, and then I want you to sort them. Okay, it is quite literally possible that you could extend CRUD repository, and that's it, job done. So I've got my user repository, it's going to be a CRUD repository. We know what the CRUD stands for? Create, read, update, delete. Yep, good. So I want the standard, read, write, delete operations. Go to town, and you know which 10 methods we're going to declare and implement for you. You could then, or you could implement the CRUD repository and then start adding extra methods, normally finders. But you can add whatever you like, in fact. So the auto-generated finders follow, as I said, the naming convention. We pass through the name. There's some clever bits in there for doing navigation. So you could have find by address zip, and if address is a nested field and zip is a nested field of address, we will actually do the navigation and usually find them, unless your class is in fact ambiguous from our point of view. So Spring actually implements these repositories for you at runtime. As I said, you can write whichever bits of code you want, but basically what it's going to do is scan. We're familiar with Spring's component scanning already. I presume we do scanning for all sorts of things like your MVC controllers and your configuration classes more recently. So now we're scanning for repository definitions, and then we go and do the magic with that. So basically, you'll find there are variations for the different implementations. So I could turn on a Mongo repository scan, and I would probably have, com.mine.mongo.repositories or something. So I could have a system which uses multiple database technologies. It's not uncommon. So you can scan and tell Spring which particular technologies it should be scanning for. So what's going on under the covers is your code declares an interface, which is a compiled artifact, but it has no behavior. When the Spring application context starts up, it happily builds proxies, which is another one of Spring's magic solutions for a lot of things, and the proxy implements the repository and implements the actual underlying methods for you. So the technology isn't scary. It's stuff that we've been doing for 10 years now and more. It's just a one new kind of application of it. And then the repository itself extends one of your interfaces, so you can just dependency inject it. Remember, talked about dependency injection? So basically, whether it's a auto-generated MongoDB repository or a manually implemented JDBC repository, service layer doesn't care. Spring just injects it, and the application moves on from there. So, what does it look like? I've shown you the kind of, I've shown you the, pretty much what you'd expect given what we've already talked of. So, I'm going to try to avoid labouring the point because I'd like to talk a bit about MongoDB. The good news with MongoDB is that by and large the code is going to look very much the same. There will be some different queries in there for those who like MongoDB queries, but most of the underlying code and logic is fairly transportable from one system to another. I have a couple of slides. I'll talk about the differences. So if you are tempted to take an existing system and migrate it from JPA to MongoDB, what are some of the implications of that? And we'll talk about that as well. So if we look in at our favorite pet clinic, we have a JPA, and then due to the tireless efforts of someone actually in this room, we have a JPA, a Spring Data JPA. So of course, running on a projector, we have distinct limitation on pixels. So this is a happily working system. So here's our JPA pet repository. It implements our pet repository interface. This is our standard non-Spring Data approach. So the pet repository interface is our software contract. It advertises to the world, if you want to be a pet repository, here's what you must do. And the key word in there is what. Here are the methods you must implement. Here are the contexts you must support for someone to use you as a pet repository. And then here, we're physically implementing that with code. This is the boilerplate code that we're trying to get rid of. The code isn't particularly difficult. By and large, they're 3-4 liners. Some of them get to be 10 lines. But we've got to go and write these again and again and again ad nauseum. And of course, sooner or later, we'll get a bug in some of them, and we have to go and fix them and maintain them, etc. I can go through more if you wish. Spring Data repository. So if you look at the imports, we've imported repository comes from Spring Data. It's part of the core package. So we have Spring Data repository class, but the query annotation is specific to JPA. So it's in a sub package JPA. So if we go to Mongo, we'll again see the changes there. But by and large, we're relying, and if we look at a few more, same kind of thing. The Spring Data is that you don't have to deal with those intricacies to get the thing up and running. So the repositories are now going to map MongoDB documents to Pojo objects. Remember, the overarching model is that the what is going to return objects out and take objects in. The mapping can be completely automatic. We actually, in the pet clinic and in the book application, basically let the annotations be there for a number of different technologies in the one class model, and it works. So MongoDB can map a lot without any kind of annotations, but you can add some in there to clarify the obvious things. There's a template class for when you want to go and do kind of MongoDB type things. And MongoDB has some interesting features. It's got a MapReduce feature in there. So if you want to go and drive that, we give you some support for that, and it's not directly in a repository. There's no kind of standard API in the repository for go do a MapReduce. The app query takes MongoDB syntax, not surprisingly, which is a form of JSON, and then of course the query DSL is supported as well. So, what kind of things are you going to come up against if you're going to move an application from JPA to Mongo, or if you're going to start moving your development thinking or your development processes to something like MongoDB? So in the case of MongoDB, the object IDs, which are analogous to your relational key, are created in the client, not on the server. So if we want to have unique keys, which is a common requirement, in the relational world, you go and talk to the database server in some way or another to generate these keys. Normally. You can use the universal UID approach as well, but it's not particularly popular. If you look at most of the Hibernate and most of the JPA applications out there, they're talking to the database and saying, give me the next available key. So we guarantee the keys are unique. The MongoDB approach, being a much more distributed database, sees that as being a massive problem with hotspots and concurrency and synchronization. So the IDs are created in the client, and they're therefore a form of UUID. They're 12 bytes long. I put a little mnemonic here to remind me. So there are 4 bytes of time, 3 are for a machine ID, 2 of a process ID, and 3 is just some incrementing counter, which happens to start at a random number. 12 bytes. So I can convert those to and from a string pretty easily. They can be converted automatically to a big integer, but they're too big to fit inside a long or an integer. So the upshot of that is that whilst you can use integers and longs as IDs in objects that you will then push out to MongoDB, you will not be able to leverage the automatic generation of those IDs, because the automatically generated IDs in MongoDB are 12 bytes long, and they just ain't going to fit. So you could manually do it, and it's not hard. You could build a type converter, and when you create one of your objects out of a MongoDB document, you read an appropriate field and stick the value in. Actually, that'll happen automatically. But when we go to save one, you will generate a new ID for the persistence. Can anyone see where the problem's coming from this? In a single user application, that's not too hard. I can tick around and increment a counter. In a multi-user, where does my counter live? So don't fight it, guys. This is the way the system's designed. By and large, trying to write code to manage database-wide incremented counters is not easy. Stick with the approach actually supported and designed into the database, and it will make things easy. So my issue with porting Pet Clinic to MongoDB was that I wanted to keep the code consistent, and the code uses integers for the keys. So it's like, I'm going to have like conditional compilation in Java to change them to being strings or something. The other thing that will give you some pause to consider things is that MongoDB doesn't have an explicit type transactional model in the way that you're used to with a relational database. And a lot of these NoSQL SQL databases are similar. Gemfire is similar again. So the transactional annotation is not needed for MongoDB code. And if you throw @transactional in there and don't configure the underlying resources, you will get errors on startup. Specifically, @transactional requires a transaction manager. So if I'm using pure MongoDB, I don't need @transactional, and I don't need to configure a transaction manager. If I'm using MongoDB with a technology that does use @transactional, like JPA, so I've got some relational data and some document data, then I would configure @transactional and transaction managers for my JPA. It won't conflict with MongoDB, but do understand that MongoDB is not participating in those transactions. It has an atomic update model. It does not have a guaranteed consistency model in the same way we expect. There is a two-phase commit ability in MongoDB, but it is not the same as a full ACID transaction. So we need to kind of get our heads around that when we're starting to move across. When you're dealing with large metadata, the really strong ACID transactional model is a pain in the neck at times. You'll have to think about this so you don't build systems that corrupt themselves, but it will also mean that you'll get higher, the ability for higher throughput. So, what does that code look like? So, I can show you the effort, but I'll first of all just show you the straight Mongo code, and then I'll show you the code effort I went to migrate Pet Clinic to MongoDB. So there's another standard demo we have, which is a data book. And again, if we look at the JPA one, node of the core. We have repositories in there, and they should now be looking fairly familiar. Customer repository extends repository. We declare some extra methods. Conspicuous lack of code that we had to write. We have more comments than code, as it happens. This is your standard JPA Spring Data code. So then, what does the MongoDB stuff look like? So here's our MongoDB customer repository. And, oh look, it's almost identical. So we have a model which, because it deals with what, in fact, the essential parts of the code, in fact, look very, very similar. If you start going to throw queries in there, this is a query, then you have an query annotation, and it has happy. Oh, I can't give you 2 prizes, I'm sorry, but do you want to tell me what the query does? These are question marks, not 7s, by the way. I read that first off as 70:71. I thought, what a load of rubbish. It actually is question mark 0:1.
Parameters.
So basically, we're giving people a completely generic finder. So basically, you pass in a string and a value, we pass that in as a query, and it will go and find all documents that have that key value pair in the document. Is that elegant? Is that simple? Is that the kind of stuff you want to be able to do with a database without messing around with weird thises and thatses and something else's? So the good news with the MongoDB stuff and the other ones is that in fact they aren't hideously different. Yes, we have the facility with our query to go directly to the database query language if we wish. The query DSL would obviously look the same between both. Okay. So, in summary, Spring Data is focusing very much on leveraging the benefits we had from repositories, and we're going to implement them for you. So that's the big news. It's not a new design. It's the same design, just automated for you. Based on the adaptive pattern, and we're converting specifically a what API to a how. We do the implementation dynamically. You can override any bits that you need. You just declare your repositories as interfaces now, and we'll fill in the details based on what you coded. Mapping is inferred where possible. You have annotations to drive that if you wish. Template classes. I did actually have a template class used. I'll dig it up. I'm needing to move along on the get to the end pretty quickly. And then a range of query support. Declare a finder, and we will implement it correctly with the appropriate underlying query syntax. You can declare the appropriate query syntax on there if you wish to drive it directly, or you can use the DSL. You want to tell me what DSL stands for?
Domain specific.
Yeah, there's specific language. Over here.
Domain specific language.
There you are. Okay. End of presentation. Thank you very much for your time.